Hello friends, welcome to Smart India Hackathon 2017. My name is Prashant and I am going to take you through data analytics part. And my colleague Kapil.
Hello ladies and gentlemen, I am Kapil and I will take you through reporting and visualization.
We are very proud that we are part of this initiative. So let us start our journey through data analytics part. Let's start with agenda. What is data analytics? What is data? What we do with data? Data modeling. Know your data. Data types, data patterns. And then at the end, we'll take one example to understand all these concepts. So what is analytics? I think I'll give you one simple example which you are connected to and you will get to know that how it is part of your life. When your exams are close and you start preparing for the exams, what you do is typically you go to the universities, try to find out 5 years question paper for a particular subject, right? Then what you do? Then you collect all those questions, you create a question bank out of it. Based on that, you try to find out which question has appeared in a particular year and how many times it has come. You try to find out what is a pattern. You try to find out which is the subject or a chapter in your curriculum which has given or which has a lot of weightage. Now all this you do, and then based on all these patterns, what you try to do is you try to find out which question will come this year. So what is this? This is nothing but a prediction, right? So what do? You collect all the data, you try to know your data, you try to find out patterns out of that data, and based on that pattern you try to predict. And this is what is? This is all nothing but is a data analytics, isn't it? Probably you are not aware that you are doing this analytics for every semester. Now we'll go over very close examples which we have. In cricket, like if I'll ask you question, who was bowled out 0 maximum times on 0? And the answer is Courtney Walsh. Okay. You search on Amazon about shoes, and when you log into Facebook, you see all the advertise related to shoes. Do you know why you see all that? Because in the back end, all this data is captured, and based on that, a profile is created, and based on your profile, you see all the information. On Google Map, when you ask for a route for moving from point A to B, it gives a shortest path and time required to reach from point A to B. Do you know why or how it happens? It happens because Google calculates distance from point A to B based on traffic and various other parameters. What all these things? How we can get all these things in one place? It's just because of analytics. So now we'll understand what is analytics. So analytics is a discovery of meaning in data, converting your data into knowledge, looking into historical data to get insight for improving return on investment. For businesses, right, they have a lot of information, they are doing that business for 10 years. Can I use that data and find out different patterns, and can I use that for my business? Yes, it is easily possible. And all these what we are discussing right now is possible only and only if we have data. So now let's think about what is data. See, what happens is that we do so many activities, but we don't know that those activities are generating data. Any click which we do on Facebook is stored as a data. Any transaction we do, like train reservation, results into data. Any banking transactions which we do, that results into data. Any call we do using mobile or SMS we send generates data. Any order we place on shopping site results into data. Any surfing which we do on any social media site results into data. So anything which we do and while doing that, if you are on internet or connected to internet, that results into data. So you will understand how much data we generate in a day, isn't it? Now we'll understand the definition of data. Originally, data is plural for datum, a Latin word. A datum is a single factual, a single entity, a single point of matter. Datums are most often called data points. Data represents collection of data points. So we speak about data sets instead of data, which is nothing but a collection of data points. So today data is used in a singular or plural form, isn't it? So now why we need data? We need data because we want to take some decisions based on data. We want to find different patterns and we want to get intelligence out of it. Now let's see what we do with data. What we do is that the first time you see a data, you try to identify data sets. When I say data sets, it's nothing but a group of information. A group of information about geography, a group of information about people, a group of information about what I am doing right now. All this collection, and if I classify that collection, results into data sets. Once you get that, we try to identify different types of data model. Now it depends on what type of application we are going to do, your model gets decided based on that. So if I am going to create OLTP system or I am designing OLTP system, then I need ER model, that is entity relationship model. And if I am in OLTP, that is online transaction analytical processing, I use dimensional model, and we'll understand what dimensional model is in a few minutes from now. Then we have to identify relations between each data sets. What are those relations? They are one to one, one to many, many to many. What is one to one? We'll take a very close example. One student undergoes different, say, subjects, right? He learns different subjects. One professor is teaching one subject, but one professor is teaching to multiple students, right? He is taking lectures in different classrooms. So these are different combinations wherein you can see that there are relations, and these relations are depending upon what actions we are doing. And you need to understand these relations because based on that you are going to define your model. Once you define all the relations, you now got a data set. Now you have to identify basic keys for your data set. What are the different types of keys? We call it unique key or primary key. What is primary key? So primary key is a key which never gets repeated. A simple example is Aadhaar card number. Now Aadhaar card number is a unique for that person. Your student identity number, it's a unique for you. What is secondary key, or in some cases we can call it foreign key as well? That one your student number is used for different lectures, right? So your student ID is going to be foreign key in that table where lecture information is stored. So next part, now you got the data sets, you have keys, you have found out relations, and you have to model that data. So there are two types of things which you have learned in your curriculum. One is normalized data. So what is normalized data? On right hand side, the picture shows that there is one to many relations between names and address, right? And that is possible. You can see that Shiv has address as India and Raju has address as Mumbai and India. This is possible because maybe Raju has come for education in Mumbai, isn't it? Now this is a normalized form, because for names you have different data set and for address you have different data set. We will take example of denormalized data. On right hand side, if my name and address information, if I convert into denormalized form, then you can see that I have name, address 1, address 2 together, and same information is in one line. This is denormalization. Now why we do this kind of a things? One part is for OLTP and another denormalization is for OLAP. The basic reason is that in normalization or normalized form or in OLTP systems, most of the actions are insert, update and delete. So normalized form helps you to do these actions very fast. On other side, in OLAPs or data warehousing, you need denormalized data, because the main action which you do is querying a data, and denormalized form gives you very fast response. So these are the fundamentals that we need to understand when we are trying to design our data model. You will be working on various problem statements and their solutions, and while doing that you need to keep this in mind so that it can help you. Now we will come to data modeling, that is dimensional modeling, which is used in data warehousing, and that is the base of, you can say, analytics, data analytics. Before going to the definition of dimension and facts, I want to take you through one figure which is on the right hand side below, where there is a graph which is showing you on x axis January, February, March month, and it is a stack bar with different colors, and each color is showing one city. What this graph is depicting? This graph is telling you that in the month of January, in Mumbai, what was the sale? So these are sales figure. Now what is January, February, March, and what is Mumbai, Pune, Delhi? So you must have come across graphs in your curriculum. So what we define on axis, that is x axis, y axis, z, multiple axis, is our dimensions, and what we plot actually is nothing but the fact. So here what we are trying to plot, we are saying that in the month of February in Pune, what was my sale, and that is what we are trying to put here. If you will see on the right hand side, there is a table which has Jan, Feb, March, April, May, which is nothing but one dimension, and Mumbai, Pune, Delhi, that is another dimension. So it is a cross dimensional information which you see, isn't it? You can have multiple dimensions. You can have another dimension saying that product. So in a particular month, for a particular geography, for a particular product, what is my sale? So now you must have understood what is dimension. So in this example, we have discussed about time dimension, geography dimension, and we have discussed about what is fact. So it is a sales information in the month of March for Mumbai. So what is that? It is 9. So I can have various questions on this example if my data is kept in a particular way, that is dimensions and facts. By looking at this data, can I find out what is my maximum sale in a month of June? Which is the city in which I have done maximum sale? Which is the city where my sale is very minimum? And because it has cross dimensions, it is easy for me to find out that, which is not easily possible in normalized structure because you have to join many tables. We will continue with data modeling. Now dimensions. So dimensions are shared or confirmed dimensions. Now what is shared dimension? The word itself tells you what is that. Example is time dimension. You solve any problem or any solution which you are going to work on will have time dimension. Will have a geography dimension because we are talking about India, which is a big country having many states, isn't it? So that is called share. So you share few dimensions across your solutions. That is a shared dimension. Now we will try to understand what is a grain in a particular dimension. So grain is nothing but the lowest possible value which you have in your dimension. So we will take a geography dimension example which is on right hand side. It is showing US and Germany. So you can see that on the topmost node is all, that is this universe. Within that you have a country, that is US and Germany. Below that you have a city called Boston, Berlin, Hamburg, Berlin, right. Below that you can have a short code or pin code which we call. So in this case my grain of geography dimension is city, because that is the lowest row in my record. I think now you must have understood what is grain. Now we will move to the next concept, that is hierarchy. Again we will go back to the right picture on the right hand side. It shows you that I have all, below that I have a country, and below that I have a city. So it is a natural hierarchy. So anywhere when you come across a data, you will find there are different natural hierarchies, or sometimes they are logical hierarchies which are created for business purpose. A natural hierarchy example is time dimension. You know that for time we can start from 1 minute, then you can start half day, you can say full day, you can say 1 week, you can say 1 month, then you have quarter, then you have 6 months, then you have 12 months. What is this? It is a very natural hierarchy which you see, right. So this is hierarchy, and in this case it depends how we are going to use that hierarchy, what problem you are trying to solve. If you are trying to solve a problem which is related to share market, probably in time dimension your grain could be 1 second or 1 minute, because so many transactions are happening across this. But if you are talking about attendance of students, probably your grain of time dimension could be month or 1 week. There is no need to find out every minute whether a student is present or not. So the hierarchy and the grain of your dimensions are based on what type of problem you are going to solve. Got it? These concepts are very important when you are going to solve any problem in hackathon. Now we will move to facts. Now what is fact? We have already seen in the last part that facts is actual figure or actual information which we plot. So by definition it is a factual data, it is a real data, and that real data has to be a numeric because it is a fact. But that is not the case, because if you will see again, all these things are very logical and are very natural to us. We come across different types of data in our life, and because of that then you have to mold or understand those concepts and change your design based on that, because we are trying to solve the problem ultimately. So facts are of different 3 types: additive, semi-additive, non-additive. Now we will take example of each so that you will understand it conceptually. So on right hand side we are trying to show sales data for the month of January, February and March, and the figures are 11, 15 and 9. Now if I want to find out for this quarter what is my sales, I can just add all these 3 figures and say that for this quarter this is your sales. So I can do mathematical operations on this, right, and without doing anything I can just add, subtract, and that is why we are calling this kind of facts are additive facts. But all figures, if I will talk about and mathematical operations, then we will move to the second example where we are trying to show average temperature for a particular city in the month of Jan, Feb and March. So in Jan the temperature is 30, average temperature. For the month of February average temperature is 35, and for the month of March average temperature is 38. Can you add this or subtract if I am saying that what is the average temperature for a quarter? I can do mathematical operation, but still can I just do a simple mathematical operation? No, because it is average. So I have to apply a different rule. I just cannot simply add 3 figures and say this is what is average temperature for this city for this quarter. That is why this kind of facts are called semi-additive facts, where you have to redo all the mathematical operations which you have done. You cannot simply add them. We'll move to the third part, that is non-additive. Now let's take an example which is again close to you, is result, right? So you can see in this table, Shiva is pass, Ram is pass, and Lakshman is failed. Now these are 3 students, and if I want, can I add this? I can't. Can I subtract? No. Can I do average? No. But is it a factual information? It is, isn't it? I can say that out of 3, 2 students are pass, but on their own I cannot add pass plus plus or pass minus failed. That is why these kind of facts are called non-additive facts. I think you must have understood. So whenever you are trying to model or doing data modeling or dimensional modeling, you need to understand which are dimensions and which are the facts, and you have to classify based on whatever we have discussed just now. Again friends, these concepts are very important when you are doing any design. So please understand these concepts very well. Now we will move presenting data effectively. Now we have understood, we have modeled the data. Now is the time when we have to understand our data. So you need to find out a story in your data. So I will take again example of student and professor. The story, and you have got student and professor data. By looking at data, you may not get anything, but if I will give you a clue that I want to find out a professor who has taken 4 lectures today, or I want to find out a student who has attended all the lectures, or I want to find out a particular student taking how many lectures in a month, then you got a story, isn't it? So when you are looking at your data, you need to understand what subject it is connected to, and based on that you need to understand what is the story, or can you get some story out of it. Identify and understand the story you are trying to tell and the relationship you are looking to show. Again, right, the relation is between student and professor, but one professor can teach multiple students and one student can have multiple professors. So you can have many to many, one to many. This is what we have seen earlier, isn't it? So you need to identify that part also. This information will help you to select proper visualization, because that is what we ultimately want to see, right? You must first understand the types of data that can be visualized and their relationships to each other. For example, the sales data, right? You need to understand what you want to visualize out of that. So anywhere in the data analytics part, it is very important that I should know what problem I am going to solve, what problem I am trying to solve here, because based on that I know what I have to visualize or what I have to highlight, what I have to find out of that, because I can find n number of things from same data, right? For example, like in sales, I have geography data and I have month data, right? In a given month, for a given geography, what was my sale? I can have n number of questions out of that. But if I have another question that I want to find out who was doing this sale, and if that information is not there, I cannot visualize that, isn't it? So that's why it's very important that we understand, and we need to understand what type of data we need for solving our problem. Now we'll try to understand different data types, because you see this in your data and you need to be vigilant and you need to see whether your data is any of this type. First one is quantitative data that can be counted or measured, and all values are numeric values. So my sales data, I can measure that, isn't it? So my sales data, I can say it's a quantitative. Discrete, numerical data that has a finite number of possible values. For example, number of employees in office, or number of students in a college, or all the people in a particular city. All these are example of discrete pattern. Now we have continuous pattern. Data that is measured and has a value within a range. For example, rainfall in a year. So it's a time series data, isn't it? For every day, what was the rain? Temperature for a particular city is a continuous information, isn't it? So that is an example, and you need to understand when you come across anything and you are trying to solve a problem, you should find out which type of pattern it is. And last is categorical, the data that can be sorted according to group or a category. Example is types of products sold. So if I am talking about different types of products, the product could be mechanical products, electrical products, plumbing products. So because the number of products is very high, and that's why one has to classify them so that you can answer. And second part is because it has a hierarchy, it's a natural hierarchy. So plumbing product will not go under electrical product. So there is a hierarchy, and that's why you have to categorize them, take them under a category. Now we need to find out different patterns because they are also important, and these patterns leads to prediction. Search for patterns and interesting insight that can be a good starting place for finding your story. See, ultimately we want to find out a story, right, based on your data. So one example is different trends. So we are, it's very close that we are having a summer time, and that's why we have taken an example, that is ice cream sales over time. So you can see that gradually from March, April towards May, if you will see the trends, you will see that the people who are going to eat ice creams, that number will grow, right, eventually. So there is a trend, and this is a known trend. Sometimes you see a trend which is not known also, but this is a very known information. It's a simple time series but gives you a trend, isn't it? Correlation. What is correlation? If the way my temperature goes up, my ice cream sales goes up, which is very natural, isn't it? But this is a trend which we need to find out, and your data will give you these trends, but you should be vigilant enough to understand that trend. Last one is outliers. So everywhere there are exceptions, and we need to be very careful about outliers. In this case, there are some regions or places in your city where you will find that in spite of very high temperature, the ice cream sale is not going up. So that is an outlier. So friends, data patterns are very important when you are trying to solve a problem, and they will help you to decide your visualizations also. Now we will take an example because we have learned many concepts, right? What we have learned so far is that what is data set. Then we have tried to find out what are the keys in my data sets, what are the relations they have to each other. Then we have seen that what are dimensions, what are facts. Then we have seen that what data pattern I have to see for, isn't it? Now we will try to apply all this here, and we will try to solve a simple problem. I have taken one problem saying that I want to find out railway reservations over time period, and on the right hand side you will see, right hand side top, I have a data for Mumbai, Pune, Delhi, and for the month of Jan, Feb, March, April, May and June, and each small cell represents the number of reservations done during that. Just to clarify, in the city called Mumbai, in the month of March, I can see 105 reservations done. Okay. Now this is my OLTP data. Because I want to find out different things and I want to do data analytics, I should go for dimensional modeling here. So when I am going for dimension modeling, I need to identify which are my dimensions in this case. And I know now that you will tell me, yeah, there is a time dimension, isn't it? So Jan, Feb, March, April, May and June is a time dimension. Another dimension is also there, which is called geography dimension, which is nothing but Mumbai, Pune and Delhi. Can you tell me, friends, that what is the grain of this dimension? Probably at this moment you may not. We will go further and then I will again ask you the same question. So what I am doing in dimensional modeling, I have just got my geography dimension, that is Mumbai, Pune, Delhi. So you can see the figure which is on the right hand side, and I have got a time dimension which is Jan, Feb, March, April, May and June, and both these dimensions are connected to reservation fact. So what that fact is? It tells me that in a given geography, for a given time range, how many reservations are done. For example, in Mumbai, in the month of Jan, 100 reservations are done. So accordingly, I will put all the data which is there on the right hand side in my typical table into dimensional model form. Now in this case, my time dimension grain is month and geography dimension grain is city. Okay. Now we have done this dimension modeling, and let us see whether we can find out different information out of this. If we have a question that I want to find out a month in which maximum reservations are done, and the answer is that in the month of May for Mumbai there were 300 reservations and that is the max. Can I find out minimum reservations done in a particular city? The answer is Delhi in the month of Jan, 90 reservations. Can I see some trend in this? Guys, again we have to find out different patterns in this. So if I will take just a Mumbai and all months data, can you see some trend there? The trend is that from Jan, Feb, March, April, May and June, the trend is that from Jan to March it is quite straight line, but in April and May the reservations have gone high. Do you know what is the answer for that? It is a pattern, it is a trend, and in June it has gone down again, because this is the time where most of the schools have vacation. So now you got the answer, because you could find out a trend in that. Can I use this for my business? Yes, absolutely. When I am going to plan my trains, I can use this information, isn't it? Can you see a common trend between Mumbai, Pune and Delhi? Yes. Both the cities, or all three cities in fact, are showing the same trend, that from Jan to March it is quite straight line, but in May and April it goes up and in June again it is going down. So all this information and all this insight is possible when you arrange your data, when you are reading your data, and when you are conscious enough to find out different patterns, different trends, different data forms in your data. Now I will hand over to my colleague Kapil for report session.
Okay, now let us start with reporting and visualization. So far what you have seen is how to capture data and how to model it, how to structure it also. So having modeled it, structured it and stored it in some database, the next thing we need to do is basically present it, because it does not matter how much data you have, what matters is basically information that you are taking out of the data, because that will really help the business to grow or to make some predictions about the trends in the future. That is where reporting and visualization is very important, comes into the picture. So in case of report, what is a report? Report is a document that contains information Before report, it is just a data which is modeled so that we can generate the information out of it. So report is actually information, so it contains information. It has a narrative, graphic or tabular form, and a basis of preparing report is basically ad hoc. It can be ad hoc as per the requirement, periodic, recurring, then regular or as required. So periodic means maybe quarterly data is a periodic. Recurring means maybe every day you are gathering the information and creating a report out of it, and so on. So report may refer to specific periods, events also, means a report of a specific event, occurrences or subjects. So the sole purpose of the report is to collect and present the data so that it can be analyzed, it can be used for a business purpose to move ahead in a business, to take some decisions. So these are different type of reports. There are annual reports, which are basically annual reports. Example of annual reports is reports of a company, financial reports of a company. Then inspection reports, expense reports, those are normally required in an organization about the expenditure people have done. Then there are census reports. You know, these are our census reports. Just election has been over, so for election to make some predictions, analysis, census report is required. There are scientific reports. Now, if you look at the scientific reports, it has a specific structure. There is the abstract, there is the introduction, and so on. These are used by the scientists to publish the papers. And there are appraisal reports. Those are needed in most of the time organizations to appraise the employees. Normally report has two forms, one is tabular and other is visualization. In earlier session about data, if you have seen, there was a table also, tabular report also, and there was a report that was a visual, that is a bar chart. So tabular reports you normally know and they are widely used, but visualizations are most important and they are very powerful and effective. Why is it so? So why visualization is the question, right? Pictures are worth 1,000 words. Just one picture can cover up whatever you want to say, maybe a para or a lot of things. You can just put one picture in front of people and they will understand. So are the smileys or emoticons which we use normally during the chats. Oldest form of communication, as old as 30,000 BC. So to start with, humans, they started with drawing the pictures in the caves. So it's the oldest form. Communicates more information than a table in a much smaller space. So that example we will see later. So in a very smaller space you can just show a visual which is for maybe a much larger table and which will be taking a larger space. Gives the viewer the greatest number of ideas in a shortest time with the least ink in the smallest space. So again, just looking at the visual, your brain starts thinking on it, because in a brain also, more than words, how the brain stores the information is visually in the form of some figures. So for a brain also, it becomes very easy to map the visual inside, and immediately brain starts activated and floods with ideas. So that's how the visualization is very powerful and effective. Now, importance of visualization. For example, notice the table below and try to spot the month with the highest sales. So if you look at this table, then it's a month and sales. So there are months and there are figures of sales. So months means dimension, sales means facts. Now here we can look at the table and come up with, say, May is the highest sale and maybe March is the lowest. But Still looking at it, it takes some time to visualize and analyze this thing, means highest and lowest cells. But if we just look at this visualization, immediately just by looking at it we will come to know that March is the lowest and May is the highest. So it becomes very easy to start our analysis in mind with. Okay, so this is how the visualization is powerful and very, very effective. Now, what are the goals in visualization? There are two specific goals. One is explain data to solve specific problem, and second is explore large data sets for better understanding. Explain data now. So it's some visual we put in front of the user and direct the user along with along a defined path. So if you can see the image, then what it shows is basically there is a visual and user has a question already in mind. So user will look at the visual and then the visual will answer the question of the user. So user starts with a question in mind and finds the answer from the visual. So it becomes very, very easy to find the answer from visual. So here for example, which country has the highest sales value? Below visual can answer this question very quickly. It's the United States. And lowest sales, if somebody will ask, then we will say Japan. So in matter of no seconds, it becomes very easy to find out. So to this type of visualization used in many scenarios. For example, to answer a question, that is how much sales did we have last quarter, it can be answered very fast and similar questions in mind. Support a decision to take some action in the future. For example, we need to stock more football jerseys as they were sold out on most days last week. So based on that, you can increase or decrease your stock of the football jerseys. So support a decision, communicate information, information about say revenue, means revenues are is on track for this quarter or not. It can be communicated very, very effectively. And also sometimes you compare also this quarter and last quarter or last year's quarter. Just by putting it in visual, it becomes very easy to find out. Increase the efficiency. This technical specification is the most viewed section in the product range. So it should be given more visibility. So user, in this case what we are doing is we are focusing user to the appropriate section in the report, so that the time of the user is saved, or we are just catering to the specific need of a user effectively. Now next is explore large data sets for better understanding. Now the term you are aware of, that is big data. It's a really like avalanche of data, so many data that comes in front of us, and for normal eyes it becomes very difficult to find out any meaning or get the answer from the data. And in this case visualization is the very powerful tool we can use. Exploratory visuals offer the viewer many dimensions to data set or compares multiple data sets with each other. So we can, if we, in case of visualization, we can present the data with multiple dimensions which may not be possible in the tabular data set. So multiple dimensions we can show the user, or we can compare multiple data sets also. So how this process starts? User doesn't have any question immediately in mind, so we present the visualization to the user with a multi dimensions or multi data set comparison. Then looking at the visualization, user will focus on specific dimension or specific data set based on the visual, and then the question arises in the mind of a user, and again visualization or the visual is there to answer the questions. So that process becomes very, very smooth, crisp and effective. So invite the viewer to explore the visual, ask questions along the way and find answers to those questions. So this is about exploring large data set. Here also that is one of the goal of the visualization. Now we have covered in a earlier session, Prashant has covered basically about the data and data patterns, data types. So data relationships are also very, very important as far as we need to find fix on which visual we need to use in our report. So there is a normal comparison where basically it's a simple comparison of quantitative values of subcategories. For example, number of visitors to various websites. There are different websites, maybe Google or some technical website or Amazon or Flipkart and so on. So if we just want to compare the number of visitors coming to the websites, then it becomes a normal comparison across that values, that is facts, and website becomes the dimension. Another relation between data is time series, that is tracking the changes in values of a consistent metric over time. So monthly sales is one of the example of time series. Another example is stock market charts. So daily, on a daily basis, stock values change, and so we can show the visualization based on a day basis. Some people in stock market, they also use the hourly basis visualization to plot the stock values, and they predict where the stock will go, up or down, and they just make their trades on based of that. One of the example you already know is about basically what I would say rainfall in the year. Then ranking, where we want to find out the highest and lowest values, and in your case also it's a college results where we are interested in most of the time finding who is the highest, maybe who is the lowest, and so on. So this shows how two or more values compare to each other in relative magnitude. Example, historical weather patterns ranked from hottest month to the coldest. And another example which I just mentioned is about the ranks in a college, university. The next relationship is part to whole relationships, where there is a part figures, and we want to compare those with a whole figures. So this shows the subset of data compared to the larger whole. For example, percentage of a customers purchasing specific products. So if in this example, if we have a product and or if we have a suite of products and customers, then we can always look at the customers. We can plot a graph, and normally in this case it's a pie chart. You can plot a pie chart, and each slice represents one customer, and that pie represents the percent of the purchase by the customer, and from it we can immediately analyze who is the important customer for us. The larger pie, the important customer. That's how it will be easy for us. So this is about data relationships, and now we will go into the actual kind of visuals we can use. I will just cover a few of the visuals which are normally most of the time used. One of the thing is bar chart. Now bar chart are versatile. They are best used to show change over time, that is time series, and compare different categories. Now categories are, you can take it as a dimension, and the fact, that is values. So there are a few variations of bar chart. Vertical bar chart is there. It is typically called as a column chart, and there is basically horizontal chart, that is called as a bar chart. If you look at the naming convention, horizontal is called a bar chart and vertical is called a column chart. So in case of vertical, it is best used to for chronological data. Time series should always run left to right, and or when visualizing negative values below the axis. So normally this column chart is used for a time series, and horizontal is, as we have seen in data relationships, horizontal is most of the time used for a ranking kind of data, if you want to rank the data. And sometimes you may have a long category labels, then also in that case that's horizontal chart becomes very handy and easy. So in general, in bar chart, if you have understood, there are two things. One is dimension and facts. Basically dimension means categories, and facts are plots on the bar chart. Normally this dimension has a subdimension which is called a series. So there is a category. For example, in case of in case of say a column chart, January is say a dimension, time dimension, and we can add other dimension also. That is in case of bar chart we call it as a series. So we can have for example in case of rainfall, rainfall in January for multiple cities. So each city becomes the geography dimension, and it is called in terms of bar chart as a series. So there comes the stack bar chart. If there is a single dimension, then just normal bar chart, that is column chart which we have seen earlier, is sufficient. But if there is a multi-dimension, means a dimension, one main dimension, that is say time, that is January, and there are multiple cities, that is another dimension added, then in that case you have to have basically go for a stack bar. So okay, stack bar is one option where these are the vertical bars placed one on another as it is shown in the figure, or you can place those bars side by side grouped under core dimension, that is time. So that is a stack bar. Sometimes what happens in case of stack bars, we are not interested in actual facts, means values, but we are interested in percent over the whole value, means 100% stacks are best used when the total value of each category is unimportant, and percent distribution of the subcategories is the primary message. In that case you will use 100% stacked bars. Now next is pie chart. That is part 2 of the relationship, it is used for that. Pie charts are best used for making part 2 comparisons with discrete or continuous data. They are most impactful with a small data set, because if there are large data sets, then it becomes very clumsy and untidy to show the pie chart, because as a rule you shouldn't have more than a 10 or 15 pies in a pie chart. Otherwise it becomes very means user cannot be viewed properly. So in a pie chart, standard pie chart is shown in the figure, and to have some aesthetic look, normally people use donut charts, and so it's a stylist variation that enables the inclusion of a total value or decision element in the center. So there is a space in center, you can just put the total value there. And one of the important thing which we need to keep in mind in pie chart is the whole, means it is always 100%. So all the slices should sum up, and when we add them they should make the 100%, not more than that. Then there is a line chart. Line charts are used to show time series relationships with continuous data. They help show trend, acceleration, deceleration and volatility. A typical example line chart is basically a stock market charts, where stock prices are basically plot, means maybe closing prices are plot on the as a line chart, and people find out the trends out of that line chart to predict the prices of the stocks. So line charts are important from that perspective. Trending basically means is the price will go up or go down or whatever. The area chart is a kind of line chart, you can say, but it can represent volume also. So same example I will take in a stock market stock chart. Each basically that stock comes with a volume. So if you want to look at the volume, then area chart is very effective. So there are variations, basically new one is area chart, normal area chart, standard area chart, then stack area chart and 100% stack area chart. It is the same meaning as we have seen in bar chart. Okay. There are so many libraries you can use when you are building a solution or building your idea in Hackathon, the libraries are like one of the most popular is d3.js. Then there is another which is very good is JavaScript Infoviz, and another is HighCharts. What we found, HighCharts is very simple to use, so I'll just show you some examples based on HighCharts. D3.js is also effectively a very good library, but it is based on the core elements of the visualization. HighChart is we can say it is a kind of wrapper over that, so it becomes very easy to write a code using HighCharts. So it's a pure JavaScript based charting library meant to enhance web applications by adding interactive charting capabilities. So not only you can just create the charts, but you can make the charts interactive too using the HighCharts. Provides wide variety of charts like line charts, SP line chart, then area charts, bar charts, pie charts, and so on. Bubble charts also. Charts are drawn using SVG, that is scalable vector graphics, in standard browsers like Chrome, Firefox, Safari, and IE. So they support multiple browsers. That is a good news for us. A basic understanding of JavaScript, HTML and CSS is required. So you must be conversant with these three technologies. You must know JavaScript, you must know how to write HTML, and you must know CSS, cascading style sheets. It is flexible and very simple to use. It is free also, free to use, means in case of non-commercial applications you can just use it without a license, means licensing or anything is not required there, and it has a very simple configurations. When you are writing a code, you can configure, means write the configuration very easily. And below is the download link, http://www.highcharts.com/download. From here you can download that library. Okay, now go to the examples. Column chart. Okay, so here chart is we need to provide the type of the chart. So we are saying here it's a type is column, so that HighChart will understand it's a it needs to draw the column chart. Then there is a title, monthly average rainfall, which we already seen in the that specific chart. Subtitle, that is source worldclimate.com. Then we need to configure x-axis, always categories on x-axis, so we are just providing the array of the categories on the x-axis. Now here we have hard-coded the values of categories. In actual application when you are developing, it will be dynamic. So you have to get these values maybe using the REST API or something, where you can directly assign this, get these values here as an array. Then we need to define the or configure the y-axis, which has a values, that is facts, and there is a title parameter for y-axis, which shows the label for the y-axis. Then we need to configure tooltip also. Tooltip has different configurations regarding how we want to layout and look and feel of the tooltip that we need to configure. So it's a header format, then point format, then footer format, and other stuff. All the information and details you can have a look at HighCharts site, or you can download the documents from the site. Detailed documents on how to what are the configuration parameters and what are other parameters. Now, while plotting the bar chart or column chart or those bars, what is the padding and what is the border width? All these things are like cosmetic things, look and feel. They are to mentioned here. And important part is the series, that is the facts part. So we are configuring facts here, and it's a multi-series. So it's a Tokyo, New York, London, and Berlin. So under the basic dimension as a time, there are geographic dimension, which is we can call it as a sub dimension here. So there are four geographic values of dimension, and its data is in the form of the array. Again, this data you will be basically fetching dynamically from the server and database, maybe using a REST API or some other technique. And then we are actually written the code to draw the column chart, and this specific line, it is basically showing the how to how to create a column chart. In the same way, we can look at other charts, like here there is a line chart. Other things are same, like there is a title, there is a subtitle, there is a x-axis with x-axis labels, and there is a y-axis, and we are seeing temperature here. So these are the facts, and these are the dimensions, and these three are the, it's a legend, and these three are the basically sub-dimensions: Tokyo, New York and London. In another piece of code, about the line chart, we can see how we can configure the legend. So again, legend has sub parameters like what is the layout, vertical or horizontal, then align the text to the right or left, and so on. So it's a kind of layout plus cosmetics and both. So you can configure legend this way here, and it will be visible in the chart. If you don't configure, then legend is not visible. So that's your call, but most of the times it is always better to show the legend in a visual. So it becomes very easy for the user to understand the meaning of the visual, means bars and other stuff. Now this is another example of where it is a pie chart, means part 2 of the relationship, and so it is about browser market share at a specific website 2014, and one of the slides we are just highlighting to start with. So it's a Chrome, so it's a tooltip which is saying that Chrome with a browser share 12.8. If you click here, then it is highlighted now. So it's a kind of animation which is inbuilt in HighCharts. You don't need to work on it at all. If you go for a say d3.js, all such a stuff you need to code by yourself, means creating that slice, and then creating these animations, then you need to code these tool tips and everything. So if you look at here in a pie chart code, in a series, what we are saying here, this I is one of the sub-dimension, one of the dimension basically. So what we are saying here is that we need to select when we are showing up the chart. So these things are inbuilt in a HighChart, so it becomes very easy to use the HighCharts and basically create the effective visuals out of it. And now we will also see what are the do's and don'ts. So these are the do's and don'ts which you need to look into when you are creating any visualization. So one, do use one color to represent each category. So each category should have a single color, so that immediately by looking at the visual we will be able to make out the difference in the categories. Then do order data sets using logical hierarchy. So ordering is very important. It becomes very easy to get the meaning out of the visual if it is ordered properly. Do use callouts to highlight important or interesting information. Again, if it is supported by the tool, then it is possible, but it helps many times. Then do visualize data in a way that it is easy for readers to compare the values. Do use icons to enhance comprehension and reduce unnecessary labeling. So, instead of labels you can always use the icons if it is possible. If you are creative enough, then you can come up with such icons also. Don't use high contrast color combinations such as red, green or blue, yellow. So, always it is better to have a soothing colors in the visualization. Don't use 3D charts. Some tools support 3D charts, but the problem with 3D charts is they can skew the perception of the visualization. So, it is always better to use the 2D charts. It gives a better effect and way to analyze the data. Don't add chart junk, that is unnecessary illustrations, drop shadows or ornamentations distract from the data. See, keep the visualization very simple so that user is focused highly on the data and the way it is represented. Otherwise, if you put such a things, drop shadows and all the aesthetic stuff, user may get distracted from the analysis. Don't use more than 6 colors in a single layout, so that it will be very clean to look at, and don't use distracting fonts or elements such as bold, italic or underlined text. So, in a nutshell, basically keep the visualization very simple so that what stands out is a data that is presented visually.
Great, we had very nice session. It was fantastic to meet you all and discuss on all these things.
Yeah, and below the screen you will find a comment section where you can provide your feedback, or you can ask any questions or queries if you have. Thank you.
Thank you.